Hello everybody. Now in second part we will discuss the various kind of matrices. First is the idempotent matrix, which matrix is known as a idempotent matrix. If there is a square matrix A is multiplied by itself, means A is multiplied by itself, A square is comes equal to the matrix itself, that matrix is known as a idempotent matrix. Similarly, periodic matrix, A square matrix, A is called periodic matrix if a raised to power k plus 1 is equal to a, where k is any positive integer. K is a least positive integer for which k a raised to power k plus 1 is equal to a, then k is said to be the period of a for which k is equal to 1. Suppose if k is equal to 1 you are going to put, you will get the idempotent matrix if you are getting equal to a. But more than that you are taking, and if it is comes equal to a raised to power k plus 1 comes equal to the matrix itself, then you can say that is the periodic matrix is there. We get a square equal to a, then we call it is to be idempotent matrix. Similarly, nilpotent matrix is there. There is a square matrix, A is called the nilpotent matrix of order m, provided it satisfies the relation a raised to power k is equal to 0 and a raised to power k plus 1 is not equal to 0. If a raised to power k is going to become a 0, that is the null matrix you will get. Then for the next one means, suppose a square is equal to null matrix is coming, then a raised to power 3 should not be equal to the null matrix, then that is known as a nilpotent matrix is there. Here is k is the positive integer and 0 is the null matrix and k is the order of the nilpotent matrix of A. Similarly, involuntary matrix is there. A square matrix A is called involuntary periodic provided it satisfies the relation A square is equal to the identity matrix. If the matrix is multiplied by itself, then you are getting the identity matrix there, that is involuntary matrix you can say, where I is the identity matrix. So have a look. Now the transpose of a matrix, if there is any matrix is given, then if we interchange its rows and columns, then the matrix you will get, that will be the transpose of the matrix itself. For instance, suppose A is a matrix whose elements are 1, 2, 3, 4, 5, 6. So if you are going to take the A transpose, that is denoted by A raised to power T or A dash you can say, then if we change the rows into the columns and column into rows, so you will get like 1, 2, 3, 4, 5, 6. This is your transpose of this matrix is there. So if A is any matrix is there, if you are going to change their rows and columns, then you will get the transpose of this one. So A is equal to this and transpose of this one, or you can say the square matrix also you can take is here. That here is 2, 3, 4. So here will also be the 1, 2, this is 2, 3, 4 is there only. So this is the transpose of this matrix. Now there is a properties. First is, if you are taking the transpose of any one of the matrix, then again you are going to take the transpose, you will get the matrix itself. Second, if A plus B you are going to add first, then you are going to transpose, or if you take the transpose of A and B, then you are going to add, it will come equal. Third, if K into A transpose you are doing, or K into A transpose will be the, if you are multiplying the matrix A by K, any scalar quantity, then you are taking the transpose, or if you are taking the transpose, then multiply this scalar quantity will get equal. But A into B transpose is equal to B transpose into A transpose is there. A into B whole transpose, you are going to multiply them, then you are taking the transpose, or if you take the transpose of B is multiplied by the A transpose will be the equal. So these are the properties. Have a look. Okay, so one problem we are taking, there is a matrix A, 1, minus 2, 3, minus 4, 2, 5, and another matrix B is there. We want to show that AB whole transpose is equal to 8B transpose into A transpose is there. See now, look at here. So first of all, we can do the AB first. So what you will get AB, first row will multiply with the first column is there. So 1 into 1 plus minus 2 into minus 1 plus 3 into 2. First row with the second column 1 into 3 plus minus 2 into 0 plus 3 into 4. Similarly, second row with first column minus 4 into 1 plus 2 into minus 1 plus 5 into 2. Second row, second column minus 4 into 3 plus 2 into 0 plus 5 into 4. So here you will get AB, this is 1 plus 2 plus 6, this is minus 4 minus 2 plus 10. Here you will get 3 plus 0 plus 12 minus 12 plus 0 plus 20. So this is equal to 6 to 8 or 1 9 minus 6, so this is plus 4, this is 15 and this is 8. So this is your A into B. Now if we take the AB transpose, so your AB transpose become 9, 15 because row will change into the column and column will change into row. So this is your AB transpose. Row will change into the column and column will change into the rows. Now we must check for this one. So first of all you must about to take the A transpose is here. A transpose you will do. So you will get 1 minus 2 3 minus 4 2 5 and B transpose. This is 1 3 minus 1 0 2 and 4. This is a B transpose. But now you want to do B transpose into A transpose. So now here we are going to do the B transpose into A transpose here. So this first row is multiplied with this first column. So 1 into 1 plus minus 1 into minus 2 and 2 into 3. Now thus this first row multiply with the second column again because B into A we are doing. So 1 into minus 4 plus minus 1 into 2 plus 2 into 5. Similarly, second row with this first column 3 into 1 plus 0 into minus 2 plus 4 into 3. Here is the second row with the second column 3 into minus 4 plus 0 into 2 plus 5 into 4. So finally you will get is here 1 plus 2 plus 6. This is minus 4 minus 2 plus 10 and this is you will get 3 0 plus 12 minus 12 plus 20. So this is equal to 9 and this is your 4, 15 and 8. And if you are going to take the just see now this is 9 4 and what you are getting AB whole transpose is equal to 9 4 15 8 and B transpose into A transpose is also. So therefore you can say AB whole transpose is equal to B transpose into A transpose. So it is verified. Have a look. Okay. Now the symmetric matrix, skew-symmetric matrix and orthogonal matrix we will discuss. Symmetric matrix means if any square matrix will be called the symmetric matrix if for all values of I and j, that is Aij is equal to Aj. Means if you are going to take the transpose of any one of the matrix, the transpose of any one of the matrix is you will get the matrix itself, then you can say that A is the symmetric matrix. For instance, this is the example you are taking. There is a matrix A, the elements are this one. If you are taking the A transpose, you will get the matrix itself. You will change the rows into the column into rows, so you will get AHG. Same you will get HBF here, that is GFC, and this is the matrix A itself is there. So then you can say this is the symmetric matrix. But if the transpose at any of the matrix is comes equal to minus A, means minus of the same matrix is there, then you can say that is the skew symmetric matrix. The important point is there only in skew symmetric matrix. If any matrix will be the skew symmetric matrix, in that one the diagonal elements always will be the zero. Always will be the zero. So if all the elements are zero, so at least you can presume that that may be the skew symmetric matrix, but this condition must be satisfied. So here is every square matrix can be uniquely expressed as the sum of the symmetric and the skew symmetric matrix. Means here is, if you know, suppose any matrix is given, you want to write the symmetric matrix or the skew symmetric matrix, just take the matrix and the transpose of that, just add, divide by 2. Whatever you will get the symmetric matrix. Means if you are going to change the rows and columns, you will get the matrix itself. And to get the skew symmetric matrix, just A minus transpose of the matrix A itself, divided by 2, you will get the skew symmetric matrix. So sometimes the question can be asked, just write a example of the skew symmetric matrix. So you can write any matrix, take the transpose of that, add that, divide by 2. If you are not dividing even then A plus A transpose is always the symmetric matrix, and A minus A transpose always you will get the skew symmetric matrix. To become an orthogonal, if a matrix is multiplied by the transpose of the matrix itself, and then you get the identity matrix, then you can say that is A is the orthogonal matrix. The concept is here only, if A into A transpose is equal to the identity matrix, then A inverse of the matrix will be the A transpose itself. So have a look. Now, example we are taking, there is a matrix A. We want to write the symmetric and the skew symmetric matrix is there only. See, because if you are going to do the transpose of this one, this is neither a symmetric or a skew symmetric is there. So this is already know that A plus A transpose will be symmetric, and A minus A transpose you will get the skew symmetric is there. So just you must do the A transpose is here. So what you will get? You will get 4, 2 minus 3, and this is 1, 3 minus 6 minus 5, 0, 7. This is your A transpose. Just add A plus A transpose. Just add here is A plus A transpose you are going to do. So the first element of first row and first column will be added here. So 4 plus 4 is 8. 2 plus 1 is 3. Minus 3 and minus 5 minus 8. 1 plus 2 is 3. 6 minus 6. Here is minus 8. Minus 6 and 14. You can add this A plus A, this one. So 4 plus 4 is 8. 2 plus 1 is 3. 3 minus this one, 2 plus 1 is 3. Then 6 minus 6 minus 5 and this minus 8 minus 6, and this is 14 is there. This one you are getting is here minus 8 minus 6 and minus plus 14. 7 plus 7 plus 14. So this is A plus A transpose. See, if you are going to write this one, the transpose of this one, if you are going to write the transpose of this whole, you will get the matrix itself is there. So then you can say this is a symmetric is there. This is your symmetric matrix. You can write, if you are going to write the transpose of this one, A plus A transpose, this you will get this one is itself 8, 3 minus 8, 3, 6 minus 6, minus 8, minus 6, 14. So if you want to write the symmetric matrix of any of the matrix, just matrix plus do the transpose, add them, you will get the skew symmetric matrix. Now this is your skew symmetric matrix. Similarly for symmetric, for the skew one is there, A minus A transpose you must do. A minus A transpose you will do here. Directly you will do 4 minus 4 is 0. 1, 2 minus 1 is 1. This is 2. 1 minus 2 is minus 1. 0 minus 6. Here is minus 5 this one, so minus 2. Minus 6 and 0. This is. So see, first of all the diagonal elements are already coming 0. So you can say this should be the skew, but you can check because A minus A complement. If you are going to take the transpose of this A minus A transpose, then it should be equal to the minus of this one is there. So you can take the minus common from here. You are going to transpose of this one will come equal to minus A. So from here only you will write, you will get this one or same here, but you can take the minus common from here. So what you will get? You will get this is 0, 1, 2, 1, 0, minus 6, 2, minus 6, 0. This is. So, and this is the schistomatic. This is the schistomatic matrix. You can say this one is there. Have a look. Okay, now we will discuss the adjoint of a square matrix. If any square matrix is there, we want to write the adjoint of that matrix is there. So we have taken the matrix A. The elements are A1, A2, A3, B1, B2, B3, C1, C2, C3. Then the determinant of A will be equal to A1, A2, A3. This is the sign of the determinant. B1, B2, B3, C1, C2, C3. You are supposed to find out first of all the cofactors of the elements of the determinant A. Cofactors of every element of the determinant A is there. How can you find out is there only? Just for the own convenience I have written this C is the cofactor, that C11, C12, C13, C21, C22 likewise. So how can you calculate the cofactor of this C11? Means first row, first element, first row and first column element. We are going to find the cofactors for this one A1. So what we will do, if you are going to write the cofactor of this element and this row and this column, you are supposed to delete. Then rest of the elements you must write down here. But there is a method is there to write the cofactor is there. Always you are supposed to do the minus, and this is the represent the number of rows. This is represent rows, and this is columns. Because first row, first column we are taking, so minus 1 raised to power 1 plus 1, and this first row and first column is gone, so you are getting this one. You can do the multiplication B2 into C3 minus B3 into C2, and this is minus 1 raised to power 2, so it will remain the plus 1, so the value will remain the same. But in case if you want to find out the cofactor for this one, this element for A2, so this row and this column we are supposed to delete. The rest of the elements you must write down. B1, B3, C1, C3 is here only. But minus 1 raised to power 1 plus 2 means row plus column. So this is minus 1 raised to power 1 plus 2, that is minus 1 raised to power 3, so you will get minus 1. And as usual you must multiply B1 into C3 minus C1 into B3. You will get the cofactors for this one. Similarly, you can find out the cofactor for this one. So for every element we are supposed to write the cofactors is there only. Similarly, you can write down, suppose you want to write the cofactor for this one, C21, second row, first column. So it will be minus 1 raised to power 2 plus 1. Elements will be, this is second row, first column. So second row, first column. So A2, A3, A2, A3, C2, C3 will come. And this is equal to, this is minus 1 raised to power 3. So that minus 1 into, you can multiply A2, C3 minus up to down plus down to a negative is there, minus C2, A3 is there. You can calculate it, you will get the cofactor of C21 means second row, first column. Second row, first column delete karenge, these elements we will write here only and this sign. So the cofactor of this one is always equal to, if in case if these are the even is going to, like here is the 1 plus 3 is there, so this is 1 plus 3 plus 4, so this is plus 1 you will get is here only. So likewise you can find out the cofactors, and if we write the transpose of the cofactors, you have to write the value of C11 whatever you will get here only, you must write down here. C12 values you must write down here, C13 value you must write down here, similarly here. And then if you are going to write the transpose of this one, that will give you the adjoint A. So adjoint A is nothing else, that is the transpose of the cofactors which you are getting here. Now I will take the question, then we can understand. Have a look. So now the question is find the adjoint of the matrix. This is the matrix is given. We want to find the adjoint of this matrix. See, the cofactors of any one of the elements you are going to write. This the method is there. Aij will be equal to the determinant D itself. In case if it will be the positive, if it is I and J are the sum is even, means the row and column sum is even, then positive value you will get. And if the odd is there, then you will get the negative. So you can understand from here also. So I assume then C be the matrix of cofactors of the elements in this determinant A. C11, C12, C13 likewise. So you want to find out C11 cofactor for the first element of first row and first column. So we will write minus 1 raised to power I plus j 1 plus 1. This is I, j, and elements will be first row and first column. First row and first column will be deleted. You will get 5, 0, 4, 3. You will solve this one. So 1 and this is 15 minus 0. So you will get 15 is here. Similarly, C12, that is minus 1 raised to power 1 plus 2. First row, second column. First row, second column. So you will get 0, 0, 2, 3. 0, 0, 2, 3. So this is minus 1 into 0 minus 0. So you will get 0 itself. Then C13 minus 1 raised to power 1 plus 3. First row, third column. So 0, 5, 2, 4. 0, 5, 2, 4. You will solve this one. 1 into 0 minus 10. You will get minus 10. Similarly, C21 minus 1 raised to power 2 plus 1. Second row, first column. Second row, first column. So 2, 3, 4, 3. 2, 3, 4, 3. You will get minus 1 into 6 minus 12. So you will get plus 6 is there. Now C 2, 2. Second row, second column. 2 plus 2. Second row, second column. So 1, 3, 2, 3. 1, 3, 2, 3. So you will solve this is here is 1 into 3 minus 6. You will get minus 3. Similarly for C2, 3. Minus 1 raised to power 2 plus 3. Second row, third column. Second row, third column. We will delete. So 1, 2, 2, 4. 1, 2, 2, 4. So you will get this is minus 1 into 4 minus 4. So you will get 0. Now C31, third row, first column. So third row, first column we will delete. You will get 2, 3, 5, 0. Minus 1 raised to power 3 plus 1. 2, 3, 5, 0. So here you will get 1, 0 minus 15. So this is equal to minus 15. Similarly, C32 minus 1 raised to power 3 plus 2. Third row, second column. Third row, second column. So 1, 3, 0, 0. You will take. So this is also you will get 0. C33 minus 1 raised to power 3 plus 3. Third row, third column. So 1, 2, 0, 5. 1, 2, 0, 5. So here you will get 1 into this one. 1 into 5 minus 0. So you will get 5. Now have a look. Now these values you must write down here. So C11 is 15. So this will be equal to 15. C12 0. Then minus 10. 6 minus 3 0 minus 15 0 5. So this is your C. But you want to write the adjoint A. Adjoint of this matrix. So adjoint is already we discussed, that is the transpose of the C, because adjoint of matrix A is equal to C transpose. You are supposed to write the transpose of this matrix, that will give you the adjoint A. So this will be 15, row we will change into the column 0 minus 10, 6 minus 3 0 minus 15 0 5. So this is your adjoint A. So likewise you can calculate the adjoint of any one of the matrices there. Have a look.